So these are some New Year's streams, right? New Year's streams, because I had a patron ask me about C++, because we did the C++ stuff in December with the Pico. I had a patron ask me to try and speak of the devil, and he turns up. Hey Gary, we're just speaking about you. So it's 8:45. Oh, that's all right then. So a certain patron who's just made himself known asked me to try and explain classes. So I'm trying to explain classes. So yesterday we went over the terminology and a couple of examples of how classes work. But we use C++ as our programming language because I'm learning that and we're using that for the Pico. And so I left with some homework for the guys to do. Now, I know a certain Gary has been trying his best to do the classes. So we've been talking about inheritance, polymorphism, encapsulation, and all the other tricks and treats that classes allow us to do. And we are, oh, I haven't got it open, have I? Hang on. We are trying. So this is going to be an ongoing thing. Oh, there it is. So this is going to be an ongoing thing. Slowly. We're going to try and do asteroids. Yeah, because asteroids is a vector game. Like that. Yeah, it's just lines and shapes. All sorts of shapes, all sorts of lines. And we've got a few controls in there. Yeah. So. We need to start off, if we're doing this, we need to start off at ground zero. What do we need? Well, first of all, we need some sort of shape object. Yeah, we need some sort of shape object. So yesterday we started out creating some shapes. So we've got a point. Hang on. We've got a point class that puts a point on the screen. We've got a line class that puts a line on the screen, and we have a box class that puts a box on the screen. And as you can see, line inherits point, box inherits line. And then we've used polymorphism to overload the draw routine because each one has a different draw routine. And then we put them on the screen. Now, Gary found a bug which, quite rightly, he called me up on, where we wasn't setting this. There we go. So if I compile that now, so I need to change, look, I've been testing my homework. So it's tut5 all shapes. Tut5 all shapes. And then run it. There we go. So there is a yellow dot right in the center of the screen. You may not see it, but it is there. I proved it yesterday. We've got a magenta line and a cyan box. So the homework I set yesterday was to create a shape class. Yeah, the shape class. And the reason for creating the shape class is that box is you need a make file. I don't know how to do them, mate. I just drives me nuts when I see other make files that don't work. I tried to make a task, but even that doesn't work. It won't do it. I've even created a task to do it. So if I go, is it Control F1? Nope. Oh, Control P. Oh, I keep forgetting the keystrokes. There we go. So even if I do, run task, it doesn't do anything. I've got the task in here, but it doesn't work. So I've given up. I've given up on tasks. Just rubbish. Anyway, so I set some homework to think about all the other shapes. So triangles, squares, pentagons, hexagons, octagons, blah 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 blah, and what you would need for the base class of, say, those shapes, because you can't use a box for a pentagon and you can't use it for any other shape like triangle or anything. You got to think differently. I can't get the task working. It just will not work. I have tried and tried. I can't get it working. Oh, come on. I think the key codes are different on this. Nah, look, it just has a fit. I just get errors all the time, so I abort it. I just get aborts. It's like it doesn't know where the file is. It just fails. So I just use this. Right. So you got to think. Right. Let's start with a triangle. How are we going to draw a triangle? How are we going to, without having to recode every shape? So we could write a triangle class that is dedicated for doing triangles. Could write a box class, yeah, which we have done. But the box class can also be a rectangle. We could write a class for ow, my back is killing me. We could write a class for pentagon, which is 5 sides. Then I think hexagon's 6, and we could write individual classes, yeah, individual classes that perform that task. But if you think properly, if you think logically and look at it from above, so you have to take yourself away, probably relative paths, yeah. I'll figure it out. I'm all right doing it in the command line. So if you take so you know the problem, but instead of looking at it like us coders do, you know, we need to create a triangle task. If you look at it from a different angle, so take yourself out of it and look at it from a different angle. We can base all our shapes using one base class. Yeah? So, we're going to do that. We're going to do one base class. Now, I've already done it because I've done my homework. So I've got it here. So I've got it here so I don't make a mistake, all right? But I can show you it working if you want, but I thought I would go through it. So you got to think. Right, so the first thing is calling it a name. So I called mine shape. Yeah? And it inherits oh, come on, John. And it inherits line. Alright? So, we're saying that the shape, like box, inherits line. Right? And the reason why we're inheriting... Oh no, not line, point. I was just thinking. The voice in the back of my head was going, what on earth are you doing? Right, point. And the reason why we're inheriting point, because point has the x and y coordinate. Yeah? So we're saying the x and y coordinate of the shape is right smack in the middle of the shape. Yeah? So where we're saying we're going to put it at 100, 100, that is the center of the shape. So we're going to use the point class and all the functionality that's in the point class to govern that. Yeah? So we need to create some extra variables that are reliant, that are needed for the shape class. But also need to be exposed to any class that inherits it, not calls it, but inherits it. So we need to do protected. So protected means these variables are available inside the class and inside any class that inherits it, but they are not exposed to the outside world for any calling program. So the first thing we need to do, right? Shape. If we've got the dot in the middle, that means that the shape is going to be built around it. Now, how you got to think. How can we do the shape? How can we make a base class that can do a 3-sided shape, 4-sided, 5, 6, 7, 8, 9? What is the mathematics that we need to use? Now, I put a hint in the Discord, and I'm just wondering if that person's going to shout it out. But what you need to think about is angles. Yeah? So for a triangle, it's a 3-sided shape. Vivog. I'm talking about a shape with the same angle for each side. So not like an isosceles triangle, but an equilateral triangle. Anything like that, because when you get to individual angles, then we have to think differently. But we're doing that each shape has the same angle for each sides, yeah, as a starting point. So we have to think about angles. So therefore, we're talking about a radius. Yeah. How big from the center point is the shape going to be? Yeah. And we'll default it to 1. The next thing, of course, is rotation. Right? Because we want to be able to rotate. So, for example, in the asteroids, they rotate as they fly. So we need to be able to rotate, and number of sides. And so we're going to do 360. And 360 gives you a circle, effectively. I mean, we could get the sides of a circle by a lot less sides than that. Now, we've got some protected variables, but we also need to have some functions inside. We need to have some functions inside the class. Now, last night I did the functions, and I kept repeating the function in the equations I was using. I was repeating everywhere. And one of the things that you have to remember is, if you're repeating equations or functions or code, make a function out of it. Make a function out of it. So I did. So here we are. So we're going to return an integer, and it's called getX. So we are going to get x for an angle in radians. So basically what this is saying, it's saying get me the x point for a specific angle with the constants. I'll call them constants, but the variables, but with the variables that are available to us. So to work out an x, it's Pythagoras. Yeah, Pythagoras. So we are saying return x point. So that's our center of our center, plus, and it's radius star the cosine of angle in radians. And the reason why the angle's in radians is because computers don't work in degrees, they work in radians, which is 2 pi. So a full circle, 360 degrees is 2 pi. Yeah. So 180 degrees is pi, and so on. And they're called radians, right? Now, when I was a youngster, I thought, why? They give you all this functionality. Why can't they do it in degrees? Hey ho, what you do? What can you do? So we're going to do the same thing for y. Yeah, because now we've got x, we need to do the same thing for y. So same thing, angle in radians. And we're going to do the same thing, so return y point this time. So the center of the object plus the radius times by sine, open bracket, angle in radians. Oops. So that should give us our y point. So if we've got a center point there of 100 and 100 and a radius of 50, and we say we want a 45 degree, we want to work out the point at 45 degrees from the center, that would be there. So it work out the y, which is there, and work out the x, which is there. Now, they're not the only functions that I was repeating in the class, right? There was another function that I was repeating, right? So we were going to be returning a float, which is get radians from angle, right? And so this angle is in degrees, right? So this so let's just put that in. Angle is in degrees. Return is in radians. So we're now creating a function that converts an angle, 90 degrees, 180 degrees, 270, into radians. And the way to do that my keyboard double hitting again. I'm going to get a new keyboard because I think this keyboard's starting to fail. Right, and so we need to return, and we've got to, and one of the things about C is we've got to cast. We've got to cast it as a float, right? Because angle is an integer. Angle is an integer, and if you divide an integer by any number, then it becomes an integer, and we don't want an integer, we want a float. We want a true value. So we have to convert the angle into a float, and that's how you do it. Static cast, and then you tell it what you want to convert it to. I tried that, mate. I tried that, but it came out as an integer. I'll show you in a minute, right? So if we divide it by this, right? That came out. If you ignored the static cast, it still came out as an integer. Is that right? If I just put 880.0, it would come out right. All right, we will try that. So I'm just gonna keep what I worked out, and we'll do what you say. All right. So you're saying if we do that, all right? That'll be interesting if it works. If it is, if it does work, I've learned something. Now, mpi is actually a constant within the CMath library. So this CMath library, mpi is a constant in there, and there's an awful lot of them in the CMath library. Let me see if I can find it. Oh, there was an awful lot of them. Hang on. Here we go. Oh, where are the constants? The sun is still out and I'm streaming. Yes, yes. Oh, where are the constants? I thought they were in that. Hang on.
Hi, John here. Another subscriber. Stay a while. Stay forever.
Nicomo! Thank you for resubscribing. Oh, 9 months. Get in there. Well, thank you very much, mate. Thank you. I am trying to find the constants out of CMath. I spotted them yesterday. Ah. Baby should
Oh my god, more bits? Thank you very much.
Open
You
the header
guys
file.
really spoil me.
How do I find the header file? Ugh. Oh, you're asking me loads of questions that I don't know. I thought it was in here. Oh, here it is. Got it. Here we go. Right, so these are all the constants, look. So pi divided by 2, pi divided by 2, pi divided by 4, 1 over pi, 2 over pi, and all the different connotations of different constants. So you don't have to list the constants. Search for math.h or... Oh, okay. Well, I mean, Studio Code seems to know. Pie and chips. Pie and chips. Yeah. But these are, these are constants, so you don't have to define your own constant, yeah? So that is the function. So these are the functions. These are the equations that I kept using all over the place. And when you see that happening, you then have to create them as functions, yeah? Then you can use them. So we need another one here. We need another protected function, which is void set number of sides. Whoops. And the reason I put this in it is that if you decide that you want to change your object, if you want to change your object from being, say, in a triangle to, say, be a pentagon, then we can do that. Yeah, we can do that. But we've got to make it a protected function because you only want to be able to do it from within the class, not from outside. Yeah. So number of sides. So we want to do angle. So how do you work the angle from a specific number of sides? U divided by 360, or 360 divided by the number of sides. Then, right, radians, angle for sides. So this is going to be a private variable that we haven't actually set yet. So get radians from angle, and we'll send in the angle. So as soon as we change the number of sides, we work out what the new angle for each of the thing in radians is. So we need to create our private features. Sure that the angle should be. We're only working in ints. Yeah, we're not going to be saying 30. We're not going to be saying 181.5 degrees. We're not going to be saying that. It's either 180 or 181. Yeah. The seeing as that we've got 360 degrees in a complete circle, that is granular enough for this object to work. We don't need to go into 181.5 degrees. It's irrelevant for this anyway. So we need to create a radians rotation. So that's the rotation angle in radians. And the one that we've just created, which is this one, and we'll set that to 0. So they're two internal variables that no one can see except itself. And then we need to do the public stuff. So, first things first. Need to create our constructor. So, right. So we'll do x comma int y. So that there are x and y sides. Yeah. Number of sides, because we need to know how many sides it's got. What's the minimum amount we need? I'm just checking mine. Oh yes, we need to tell it. We need to tell it what the renderer is. No, because it's 123 sides. I'm just thinking what can't 360 be divided by? 2 yes, 3 yes, 4 yes, 5 yes, 6 yes, 7 would have a tiny gap. 7 would have probably a pixel gap, maybe 2. 8 would be fine. 9 would be fine. 10 obviously. Yeah. So we're starting off with our constructors. So we can use the point constructor here, because we can send in x comma y, because we have a point constructor with x comma y, yeah, and with sides. And why are you not liking that? Oh, I know why. We are missing that. It tells me there, look. Tells me there, missing that. And then we have got this thing called set number of sides. So we can set the number of sides here. So set number of sides, and we send in sides. That's the first constructor. We can have another one. So shape, and we will grab that, where we can send, say, comma rotation, which is still using point x and y, but this time we will say set, oh, we haven't done that one, set rotation, so that's another constructor where we can just say do x and y, the number of sides and the rotation, but it's still defaulting to y, because we've defaulted, if you remember, in point in point, we defaulted the RGB values to 255, so it'll always default to white. Yeah. And then we can have another constructor as well. So this is where you think about all the different constructors that you can use. Yeah. So we've got another constructor. So this constructor can be int red, int green, int blue, and this time we need to change the method that we want to send it to. So we're going to do comma red, comma green, comma blue. Still do the sides and the rotation. Right? And I've missed something. I have missed something. Yes, I have. Right. Int R. Int R. Int R. So, radius. Right, so there are constructors. They're the three constructors that I thought that we would be using if when we use this in anger. So we need to now do the set rotation. I am double hitting on the T's, aren't I? New keyboard, new keyboard. Right. So we're going to set the rotation. So we keep the rotation that was set to us. We keep a record of it, but then radians. Come on, radians at rotation equals get radians from angle. So we're working out the rotation, the radian value for the rotation, yeah? So where's our start point going to be? Where's our start point? Right. Now we need to overload the draw, yeah? So if we don't overload the draw, it will just do the point, yeah? Because that's the one that we have just inherited. We've inherited the point class. So if we ran the draw, it would just put a point where the x, y point is. So we need to overload the draw to satisfy our shape class. First things first, we need to set the color. Draw color. So renderer, comma, col red, I think it's called, comma, col green, col blue, and 255, because that's the alpha, and we're always keeping the alpha to the max, or the opaque, or whatever they call it. Right, so now we're going to start doing our draw. So the first thing we need to do is so you've got to remember, right? So for three sides, right? So we're going to be working out each point of the three sides, yeah? So because we're drawing a line, we need a start point and an end point, yeah? So first things first, on the very first point, we need to work out where the start point is. So when we work out the second point, we know what to do. Yeah? So we're going to work out the start point. So we need to work out the current angle. and we are going to start it off as the radians rotation. So we're going to be saying, right, say this is naught. Say if we've got set a rotation of 190 degrees, the actual start angle is going to be here. Yeah, that is naught, and then we will work out each point to draw a line from there. So the first thing we need to do is we need to work out our initial x and y point. So here we go. So x1 equals, and we've already got these, get x, and we are using current angle. So we're getting the x and we're going to get the y. Now some people may be saying, but John, you can do it better than this. Sure enough, I don't profess that my way is the best way, but this is the way that works for me. And then we're going to initialize the x2 points, the 2 points. Right? Then we're going to do a for next loop where we are going to run through each of the sides. So for integer number of sides equals 1. Oh, why is the t double hitting? Right, number of sides let me do it this way. Number of sides equals to 1, and number of sides is less than or equal to number of sides, and we are doing ns plus plus. So we are going to run through the number of sides. Yeah. So just trying to think this through. 1, 2, 3. That one, two, yeah, that's right. Working that out. Right, so with the now inside the loop, we can update the current angle. Yeah. With our radians angle for sides. And that's why we're saying that for a triangle it's going to be an equilateral triangle, and all the sides are going to be the equal length for this particular object, right? Then we need to work out the x2 and y2. So let's grab this. So we're working out the x2 and y2. Then we can draw the line. So SDL render draw line. So renderer comma x1 comma y1 comma x2 comma y2. So that draws the line. Then we need to update x1 and y1 with x2 and y2. So x1 equals x2, y1 equals y2. Yeah. So we're now saying we've done that line. So the start point is there, and then we'll do that line. Yeah. And then it goes through and each line. So we should end up with a shape on the screen. So let's try it, shall we? Let's just try it. So we've got all these different shapes here. So I'm going to rem this lot out because we're only concentrating on the one. So I'm going to say shape my shape renderer. So we're going to put it right smack in the middle. Now I'm going to do something Oh, I changed it anyway. 600 be 400. No, we're going to make that 800 by 600. We're going to make it big. Going to make it big. Right. So, centre of 800 by 600 is 400 by 300. So that's the centre point. So the next value is the radius. So we'll make the radius 150. With the number of sides, we're going to say 3. Right, rotation, we're going to say 0. And we're going to give it a colour. So we're going to make it red. There you go. And then we're going to do my shape dot draw, which is the same as what we've done with all the other shapes. Right. Let's see if this compiles. Yes, it does. Right, let's see if it runs. Do we get a triangle? Yes, we do. But it's on its side. It's on its side. What have I forgotten? What did I forget? Oh, I know what I forgot. Right. So, let's make that bigger. Let's make that bigger. So we'll make that 250. Let's make that bigger so you can see it. There we go. There we go. Cos 0 equals 1. Oh, that's why it's over here. So what we need to do, and this is where encapsulation comes into it. This is why you don't give direct access to rotation, yeah? Because we need to do some pre-processing on rotation. So what we need to do is we need to bring the rotation back by 90 degrees. So if we do that, we should then have a standing up triangle. There you go. One standing up triangle. So our rotation for us is when for 0 rotation, we want the triangle that way. The computer's 0 rotation is what we've just had. So we have to then fix the rotation to make it human, human compatible, not computer compatible. And that's why we don't give direct access to rotation. Yeah, we have this function that says set rotation because we need to do this pre-processing on rotation to make it look right for the human, not for the computer, but for the human. But we have now got a shape that does anything that we want, right? So I can say, right, let's make this into a 5-sided shape. There you are, one 5-sided shape. But this sort of defeats the object of classes, yeah? Because the shape can do everything, yeah? The shape can do everything, fine. You don't have to make the developer's life easy. Just give them the shape command and then they have to work it out. But what we can do is now we can say, okay, I'm going to, based on shape, we're going to create a new class called triangle. Triangle. There we go. That's based on shape. So we inherit all the functionality of shape. Yeah? So why has that got a load of errors on it now? Oh, hang on. Have I forgotten my semicolon? Yes, I have. There we go. Yeah. So we can then take these constructors. We can take these constructors, right, and put them in here. And what we can do then is change that to triangle. We still want the renderer, we still want the X and Y, and we still want the R, but we don't need to have the sides. Yeah? So this is going to be shape. Come here. Grab that. Put that there. And we'll put that there. And what we're going to do is we're going to tell it. Oops. We're going to tell it what we need. So shape X, Y, comma R, comma 3. So we don't need this now. Don't need this here. This is redundant because we're actually putting into the inherited class the number of sides. Yeah. Same here. We don't need sides. We need rotation. So X, comma Y, comma R, comma 3, comma rotation. And we don't need this. So we'll do the same here. We'll grab that there and we'll put it at the end there. And we'll do the same with this one as well. Put the end on the end there because we don't need all that. Get rid of sides because we don't need it. So X, Y, R, 3, rotate, red, green, blue. There you go. So we've just now inherited shape into triangle. So let's put one in. We'll leave the shape there, and we'll do the next one as a triangle. Yeah. So triangle, my triangle. Render, and we don't need to give it the number of. We don't need to give it the number of sides. Now, why are you not liking that? Have I missed something in here? Oh yes, I am. I am. Thank you. There you go, mate. First points of the year. First points of the year. Look at that. First points of the year goes to Dr. Mortal Wombat. Hey. Right, that should be right now. There we go. So center, radius, no rotation. We'll change the colour, so we'll make this yellow. Red and blue is not yellow. It's not background colour, it's back colour. It's back colour, mate. You need to do back colour. Oh, don't tell me that's not working. Cool, I've got a lot of... I have a lot of commands in this bot now. Yeah, back colour. Why is that not done that? Hang on. Have I broken my bot? Oh, I could have broken my bot. No, I shouldn't have the cooldown. I shouldn't have the cooldown, which I don't. But it's not. It's doing black. It's doing black all the time. Look. It's not fine. It's not. Oh, it's not finding the colour, is it? It's not finding the colour. Am I missing something? Am I missing the colours? Oh, I'm missing the colours. Hang on. I'm missing the colours. Cheers, mate. Cheers, mate. NeoPixel. Where's the colours? Ah, HTML colours. I think I'm missing that. Hang on. No, it's there. Am I reading the colours? Yes, I am. Why is that not working then? Right, let's pick a colour out. Let's pick a colour out. That one. We'll do that one. Oh, right, there's a bug in it. I'll have to figure it out. Because it's just coming out with black. It's not finding. It's not actually finding the colour. I'll sort that out. Let me just make a note of that. I'll sort that out. I'll sort that out after the stream. Nerd snipped. Right. Right, so what was we doing? Oh, yellow. Yellow triangle. Right, my triangle. Right, so let's see if we compile. See if we run it. See if we get... There we go. One yellow triangle. And that's what you can do for all the shapes now. Is you create a class. So we'll do another one. This time we'll do the pentagon. Because that's 5, isn't it? Pentagon. Based on shape. But this one is 5. Right, let's do another one. Oh, we'll do this. It's easier to do this way. So, pentagon. Right, we'll just rem that out because that's a pentagon at the moment. And we'll make this red. It would have worked. It would have worked. It just was spelt wrong. It would have worked. Wrong position of N. Yeah, I've got it. I've got it. What's nerd snipping? What's nerd snipping? Nerd snipping is slang for the action of giving an interesting problem to a person. Oh, right, okay. Real life instances. I've never heard that term before. Right, so we should be able to compile it and run it, and we should still have the triangle and pentagon. There we go. And you can then create all. Now you can create all the different ones. So let's do another one, for example. So hexagon. That's 6, isn't it? Hexagon. So I'll stick them there. So this is inheriting our base class called shape, but it doesn't need any extra functionality because all the functionality is in shape at the moment. Yeah. So do that. Do another one. And we'll give it a different color. So we've got, so we'll make it, so we've got yellow, red, purple. Right, and then we'll redo this one because I want to see how granular we can get. If I do that and make that blue, I wonder if we will get a pretty accurate version of it. Alright, mate. You need constructors with colour names. Yes, I know. Whoops. There we go. Oh, the circle comes out pretty decent. In fact, I don't think we need. I think we could get away with less than that. Let's say, let's do 90 sides. Yeah, 90 will do it. That's not bad. That's not a bad circle. 90. So 90 sides. I wonder if 45. Or I wonder if that's start making it look like it's got flat edges. Let's have a look. Oh, that's just starting to look like it's got flat edges. But to be honest, I think we could get away with it. I think we could get away with that circle at 45. So we can draw. We can now create the circle class. Yeah. Let's create the circle class. So let's just grab this. Put that in there. Now, the circle class doesn't need rotation. We don't need to send in rotation. Because the circle does not have any concept of rotation, so we don't need to send that in. So we don't need that one there. And we take rotation out of this. And what we do here is we put 0 for rotation. Right. So now let's do circle. Circle. So let's get rid of rotation, which is that. What did we make the colour? Oh, we made it blue, didn't we? So get rid of that, make it blue. Rem out this. Right, let's do that again. Oh, the circle's not coming out. Right. Why was that not coming out? What have I missed? Aha! That's what I missed. The number of sides was still set to 6. There we go. There we go. The bigger this radius, the more sides we'll need. Yes. Yes. So the question is, do we leave it at 45 or do we boost it? Because to be honest, I mean I mean we could boost it. We could boost the I don't think this will stretch, will it? No. I mean, to be honest, 45 I think we could get away with. I mean, it's always the case because you've got to think about speed over quality, for example. So the circle is going to be CPU intensive because, you know, it always is. So if you can minimize the amount of iterations it has to do, yeah, then you make it more speedier. So if we to get a perfect circle, we would do 360 sides, yeah? 360 sides, then it's right. But we're doing 45. So basically, it is 45 sides. So that's every, what, 5? Every 5 degrees, is it? No, 8 degrees. So we're drawing a line. We're drawing a line at every 8th degree, yeah, all the way around. And I think that that would probably be enough. I mean, we could, I suppose we could go to, say, 60, if we did 60. That would be every 6 degrees. But then we're adding another 15 iterations in there. And when the circle gets smaller, yeah. So it's horses for courses, you know, it's speed over quality. So there you go. That's how inheritance and polymorphism is working in a real life scenario. So we could still carry on building all these. No, it's actually it's working it out. It's working it out. We've got 2 functions to work it out. There you go. 2 functions to work it out. So you can then create classes for each of the different sides. So what's the 7-sided thing called? Let's do the 7-sided because we reckon that there'll be a problem. What's the 7-sided shape called? Let's have a look. See if I can find it. Heptagon. Heptagon? Is it heptagon? Oops. Ooh, that don't like it. Right, I'll have to type it in. Heptagon. Heptagon. Is that's how you say it? Heptagon? So, but we need rotation in there. Right, let's just copy this then. We need rotation back in. Circle is the only one that doesn't need rotation. Let's put that in there. Put that in there. Right, let's create another one. So heptagon, because we reckon that we'll have. There was discussion that there'll be a gap in the shape. So let's find out. So right. So what colour should we call this then? What have we? No, we've not done green. Right, we'll do green. Right, let's see what that's going to come out with. Oh, it's done it. It's done it. It's got back to the top without a problem. In the homework channel, I posted the beam I've taken from the German.
Hello, John here. Thank you for following. Hope you enjoy the stream.
Okay, who's followed? Say hello. Who's followed? Don't be shy. Say hello. Right, let me look at Twitch. Where's Twitch? Ah, there he is. Welcome. Oh, NSMU table. Hello. Welcome. Welcome. Right, what have we got here? Oh, right. Oh, I see. Oh, I see what. That's what GaryMeg used when he was doing his. That's what GaryMeg used when he was doing his circle. Yeah, that was what GaryMeg was using when he did his circle. Hang on. Oh, I've got doves underneath my solar panels, and all I can hear is caw, 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 caw. Oh, it's driving me nuts. I don't know if the mic can pick it up. Hang on, let's have a look. No, it's not picking it up. But all I hear is caw, 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 caw. Yeah, this is what GaryMeg used. It is, isn't it? It is. It's the same because it's got the same error checking. Cool, but we won't use. I mean, this will be ultra fast. Yes, I mean we could do this if we wanted to, but I'm trying to. We'll stick with what we got at the moment because I'm trying to explain. I'm trying to show the concepts of polymorphism, inheritance, and all that by using the shape as a thing. All right, okay. So what's the next one? 8 side. That 8 side is a octagon, isn't it? 8 sides. So you can see what you can see. You can see how now classes can be really good. Yeah, octagon. Is that how you spell octagon? No, it's that, isn't it? Octagon. So we are now, and I just realised something. We didn't do a 7-sided shape, we did a 6. Right. Octagon. Right. We need. Let's see. Red. We've done red. What we not used. So, done them two. Done that. Done that. So green and blue we haven't done. Right. Oh, have I still got the thingy running? Yeah, I have. Right, so the heptagon, yeah, look, there's the gap, look. Can you see the gap at the top? Right, that's not easy to see. So we got a problem with the 7-sided one, right? So let's just rem out all that lot. And rem out that for the moment, and we'll just run it on its own because we need to fix how we're going to sort that out. Look, we got a teeny tiny gap. Teeny tiny. So yeah, it's not flat, is it? So this is where the using integers is causing us a problem. So, right, so we need to, let's see what we can do to our shape class to fix this problem. So, so it's this here, isn't it? So, first things first, get radians from angle. So we need to look at that. Let's find that. Get radians from angle. So we'll make that a float. Yeah. We'll make that a float. So we're going to send in a float. So, float. This is where we're going to have to cast that, aren't we? Or would that work? No, because that's dividing by an integer, isn't it? Oh, well, that would work. Alright then. Alright then. So, angle is 360 divided by number of sides, which gives us now a float. We send the float in to figure it out. Right, let's see if that solves our problem. There we go. Here we go. So we're still using it's only because we're using radians. That sorted that out, didn't it? So let's go back and redo everything. Right, so triangle. Let's get everything on there. Let's just make sure it's not affected anything else. There we go. Now, we could put box in there, yeah? Because it's a four-sided shape. So what I'm suggesting we do is, instead of calling this box, we call this rectangle. Because it's more of a rectangle, we can use that more of as a rectangle, yeah? And then we create a box. So let's grab triangle. Oh, hang on, quadrilateral. Is that what it's called, a box? A quadrilateral? Can't we just say box? Quadrilateral box. It's a box. Alright, let's do box. So we are four sides. Right. And what we're going to do is we're going to use a different constructor for the box. Right? We're going to use a different constructor for the box. So let's grab that, put it in there. We'll do box. Because at the moment we're using the same constructor for everything. So we're going to use a different constructor just to show you that we can use the different constructor. And what we're going to do is we're going to lose the colour. Yeah, we're going to lose the colour. Alright. In fact, we could lose the rotation and just default it. But we'll leave it. Alright. So, that should put a white box in there. Ooh, what's that going on there? Oh, hang on. There's my C sharp coming into play there. Forgot to rename this. Oh, I wish those doves would pack it in. Coo, 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 coo. I don't know if you can hear it. God, they shut up when I stop. No, you can't hear it. I can't see it on the mic gauge. No fireworks left. I've already talked to someone about putting an anti-bird thing in. Yeah, I've already talked to someone about they're going to go back up there and put some anti-bird edging on. There's the white box. There you go. There's the white box. Right. So there is how. Right. There is in a small introduction how we can use encapsulation, inheritance, and polymorphism to create a class that will do all the different shapes, and then create a class for all the different shapes up to, I mean, we could carry on going all the way up to 10 if we wanted to, because we're up to 8, aren't we? So nonagon is 9 and decagon is 10. Okay, we might as well get to the 10. We might as well get to the 10. Right, let's do 2 more. Right, so what's the next one? Nonagon. So 9. I'll put the other one in. Guys, give it a rest. Decagon. Right. And that's 10. Right. Put 2 more in there. We'll figure out 2 colours for this in a minute. Say I'm doing this stream on the Raspberry Pi. It's not doing too bad, is it? Little things. Right. So what colours are we going to give these? So how many have we got? So we've done quite a few. Grey. Should we have grey? 1 to 8. 1 to 8. 1 to 8. What does the Pi do? We are coding on the Pi. I am VNC'd into the Pi. Yeah? We are coding on the Pi. Look, this is the Pi. We're coding on the Pi 400. It's just there. It's just there. Right, what should we have for another colour? What should we have for another colour? We've done cyan. We've done yellow. We've done purple. They're the 7 main ones, aren't they? So, right, let's see what that gives us. There we go, up to 10. Oh, it was pink, the last one. There we go, up to 10. So there, hopefully... Gary, are you still on, or have you sodded off? You still on? So there you go. That's. Do you understand what we've done to make all these shapes using the encapsulation, the inheritance and polymorphism to do it? Because that's what I was trying to... You think so? Well, I mean, the code's going to be in Discord soon anyway, so you'll be able to look. So you got to remember that even though we're creating classes based on shape inherited the point class, and we overloaded it, yeah. So polymorphism to change the draw class. Now, for this to do this, we can use that shape class to define all these other shapes, yeah. So we could have a class that defines the ship, because if you think about it, it's an isosceles triangle with a kink in it, and it blew up. Yeah, the asteroids are various sides, right? So we've got, that's a 5-sided shape. That looks like a 6-sided shape. The only difference is the radius is, for every side there's a different radii, yeah? There's a different radii. So if I go into, so the asteroid class, this is the asteroid class, yeah? So we have a random, so these are the random velocities, yeah? So each one has got its own velocity, but then it's got a radius, but on its, as we call it, the vertices, the radius is randomized. The radius is randomized, so it means that it's not a perfectly, it's not a perfect square, it's not a perfect triangle, it's not a perfect hexagonal, it's wonky, yeah. So that's how we've created a class that's the perfect class. So if we wanted to create an asteroid class, we could use this to modify that shape class and overload it. So we could take the shape class and then create and inherit it into another class called wonky shape or something, where each point has a different radii, yeah, and then we join all the points up, yeah. And same with the ship, because the ship is just because we've got a UFO, look, so this is the UFO that draws the UFO, and this draws the UFO, but it's only one class, and when we send in the size, where's the size? Here we go, size. All it does, it's got a multiplier, so it multiplies out all the vectors, yeah? It multiplies, and then we still draw to those vectors. So where's the ship player? That's it. There's the ship. So, homework, if you want to do it. The homework, let's get this fired up, is to create classes. The homework is to create classes to replicate the shapes that are on here. Yeah? So we need an asteroid class that will generate a uniquely shaped asteroid. Yeah? We need a ship class. we'll need a UFO class when it comes on. But you can still use the classes that we've just defined in the test program. All we need to do is just modify it. Now I'll do it as well. So on the next C++ stream, get out of the way there. Oh, I thought I'd missed it. Thought I'd missed it. Oh, have I got the sound on? God! That UFO is accurate. Got him. That UFO is absolutely monstrous. So, now, hopefully you've got the core concepts. So if we want to now build asteroids, let's get the classes that generate. Create the classes for the three main things on there. One is the player. We need a player class, yeah, that is derived from either a shape class or whatever. An asteroid that can be derived via the shape class, and to be honest, the asteroid is a set number of. Hang on, let me just have a quick look. Is it a set number of sides? It's constants. Here we go. Average number of vertices on each asteroid, and we've got 10. So that's the average. So here what it's saying is 10 plus 1 plus 10 divided by 2, so that's 5. And then we do a random number of 15. So we do a random number of 15. Yeah? So that'll give us a random number of the asteroids, the number of vertices. So that's the number of draw points. Yeah? The number of draw points. Which we've already done here. Because the number of draw points is in the shape class. Alright? So let's minimize all this lot down. Let's minimize all this down. Get into the shape class. Box. Triangle. Right, so we're in the shape. See, at the moment, when we do the draw here, we're working out the vertices on the fly. Yeah, we're working out the vertices. We're running through each side. So we're working out the two vertices, and then we're working out the next vertice, the next vertice, the next vertice. What that's doing in asteroids is we're working out the vertices up front, and then when it comes to drawing it, we're just drawing the vertices. We're not actually doing any calculation whatsoever. So that's a change to this. Yeah. All right. So I'm gonna because that's a 1.5 hour stream. I mean, I'm just wondering whether to actually do an asteroid. Whether to actually do the asteroid. Let's see. We could do the asteroid, I suppose. We could. Alright, we'll spend some time doing the asteroid, I think. So let me remind myself what the asteroid class is like. Oh, for crying out loud. Guys, give it a rest! Oh. Right. So, when we create the class, we are putting in... Right, okay. Right, so I am going to create a new file and we'll call it tutorial 06 that doesn't work, does it? See if we can create the asteroid class. So let's just copy all of this and we'll strip out what we don't need. So let's create an asteroid class. So asteroids, we've got some. So we'll try and use the same. We'll try and use the same thing here. So that was 10. What's that speed? Maximum speed of asteroids in pixels. Okay. So I might as well keep the same. Might as well keep the same name. So average number of vertices in each asteroid. You gotta go Tesco's. I'm doing this for you. Max starting speed of asteroid. No, it won't be shut down today. I don't think it'll be shut down today. It probably would have been shut down on bank holiday. They deliver. Maximum speed of asteroid in pixels. There we go. Yeah, Asda would have been open yesterday. Right. What else? Have we using any other random number? Ooh, what's that? Royd Jag. Let's get the... Oh, we'll leave them at the moment. Royd Jag. Jaggedness. I don't know if that's a word, but that's what I put in my comments of the asteroids. So 0 equals none, 1 equals lots. Right. So we got to figure out what we're going to be using. So I think I think we're going to have to, we'll have to use the line, because I think the shape is too much for us. I think the shape is going too far, but we can use the characteristics of the shape. But then again, we could still use the shape. Just don't have sides. Right, so we need a struck. We need a struck. So we need a struct called so it's vertices for many. So it's, what's it for one? If it's vertices for many, what is it for one? Oh. It is definitely vertex. Okay. How are we using? How are we using integers? Yeah, we'll use integers. So x. I don't know. Well, I don't think we default them, do we? In structs. Hang on, let me just look up a struct. No. Cool, everything's different. That doesn't look right. Yeah, I thought it was. You put the name at the beginning. Whoops. Thought it was. I'm going to forget about that website. I'm on the official C++ website now. And there is no initializations. Right, okay. Thank you. Doesn't seem to suggest that you can initialize it. Right. So we've got our vertices. What else do we need? What else do we need? So vertices. Right. So we've got our vertices. I'm just trying to think if there's another structure I need to put in there. Angle, we're all right with. Radius, we're all right with. Velocity. But we can use the struct for the velocity, can't we? Yes. Okay, right. So what we're going to do. So I initialized the asteroid with X, Y, radius and level. So we will do the same thing. We're going to copy shape. I'm going to copy shape because it's not quite the same as shape because we're putting in sides and we're not doing that now. So let's just copy that. Let's go down the bottom. Right, so this is asteroid. So we're still going to use point because of the XY. But the problem is we need a way to export X and Y. So let's put that in public. Right, hang on. Right. Let's put that in public. So, vertex. Ooh, come on, John. Go on, my hands are getting cold. Right. Now, why are you not happy? Vertex is undefined. What? Oh, small v. Oh, my bad. Oh, I did little as well, didn't I? Right, so we need a way of figuring out where we are. So we need a way to send that outside. We're not going to be modifying from outside, I don't think. Hang on. No, it's all done internally. We just need to know when we're out there. Right. So that allows us to read where the asteroid is from the outside. So, constructors, what do we need? We need the radius, we need rotation, we don't need the number of sides, because that is going to be... oh! Now, this is the number of vertices. I think that's how you spell it. No. Vertices. There we go. Number of vertices. No, it's not going to spell it. Oh. Right, number of vertices is a random number. So we'll say 10 to start with, because we're going to work that out when we do the constructor. Get X, get Y. That's the when we're going to be drawing, getting the angle. Number of sides is irrelevant, because we're talking vertices. Private. Right, so I need... Oh, I can't spell vertices. I-C-E-S. Vertices. And we need... we've got a constant, haven't we? Number of vertices, asteroid. So we're going to say that times 2. So it's a random number between the maximum and half of the maximum. So that's 15. So if we do 20, we'll be fine. That should be okay, shouldn't it? Should be able to do that. Angle change per frame, so that's the rotation. That's the rotation. But that's the rotation, isn't it? Why do we need that? We've already got the rotation. So I can work the rotation out. So we've got radius x, y. We don't need number of sides. Just need the level. What's the level used for? Oh, it's used for the velocity. It's used for the velocity. Right. So we need that, we need that, we need that. Because we're still working in radians. We don't. Oh no, we need that. Radians for rotation. So the asteroid, we are X, Y, radius, and level. So radius is there, so we need a new called level. What do we need? Do we need to store it? We don't need to store it. Don't need to store it. We're only going to be using it in here. So we don't need that. We don't need this lot. Because we'll set the colour outside of the constructor. Right, okay. So we need some private, so float. Delta X velocity. Float delta Y velocity. Float delta, oh no, velocity X. Oh, this is going to be very boring for you guys, I suppose. Really wanted to be the homework. In fact, I might still, but we'll get the constructor done. We'll get the constructor done. So, we've got rotation. We've got the rotation. Right, so we need to create the vertices. So what we need to do is create the vertices based on the number of sides, and then we need to jag it. So we work out the number of sides, and then we change the radius of all the vertices. So that's something that we need to put in there. Maybe the vertices needs to be changed. It's not X, Y, is it? So it's gonna be, let's run it again. Can't pause it. That's 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10. But they're all different radiuses. So it's not XY. The vertices is not XY. Because we're going to have to work out the XY because of the rotation. So the vertices is not XY. The vertices is the radius. It's the radius. Show how I'm rotating. It's in Python, mate. It's in Python. So it's in this drawer here. There. We're doing the angle and then applying the angle change per rotate for the number of frames. And then we work out the X and Y point of that vertices and then do it. So it's slightly different. Because we work it based off the radius. I suppose the angle is still the same, isn't it? The angle is still the same. I'm just looking now. The angle is still the same, so we can still use the shape. The only difference is we are changing the radius, so we can still use the shape. So we can import the shape. We can inherit the shape. Right, I need to spend some time on this. Right, okay. So, homework. See if you can create a simple asteroid class while I do the proper asteroid class. So what you want to do is you want to create an asteroid class that can do many different sides of asteroid and be able to rotate it every time you cycle through. So every time you cycle through here, so let me go back to all shapes. Let's go back to that. Here we go. So here, when you're cycling through, let's see if you can get it to cycle. Okay, so let's do this. Right, so let's do this. Right, so we're going to set all these. So I'm going to cheat. I'm going to grab all this lot. So just to give you an idea how to do the rotation. Paste it in there. In fact, it's here, isn't it? I think it's in there, but we'll see. Up. Right, don't need that. 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 I'm hoping this is right. Right, here we go. So we should be able to do set rotation. There we go. Right, do it this way, John. Do it that way. Now, I don't know how fast this is going to go, to be honest. But we'll find out. Right, so it's going to rotate a degree at a time. Raster lines of CPU. Wow. Right, here we go. Oh, have I still got it running? Oh, crap. That's been running all this time. Right. Will that... Yes, it does. Will that... No, it doesn't. Right. What am I miss... Oh, that. I'm missing that, aren't I? Right, okay, I am missing something, and I put it in Gary's thing. I think we need to set the background to black. Hang on a sec. I think we need to set the background to black. Yes, there. That's what we need. Let's get rid of that. So every time we do it, we set the background to black and then run it again. There we go. So that's how you can get the rotation. That's how you can get the rotation done. Hey, Mikroman. Hello. Oh, the movie's complete. All right. Okay. Well, we've managed to create a class that does shapes, and now we've just done it so it rotates. The homework is to create an asteroid class that has the requirements of an asteroid can have many different sides, and it needs to be rotating. It needs to rotate. Now draw a rectangle on the center. If you know, you know. Now draw a rectangle on the center. Oh, I get what you mean. I get what you mean now. I get what you mean now. Yeah, so put the rectangle on the centre. It does look a little bit like that, doesn't it? So that's the homework, right? I'm going to do it, but I'm going to make it have all different jagged sides and everything. But the homework is to create an asteroid class that has a random number of sides. And has a random rotation. Yeah. So that is the homework. That's the homework. So we're going to slowly create the asteroid game. I'll create the asteroid with the jagged edges, but you guys see if you can create the asteroid class with a random number of sides and a random rotation, because then that will be your generic asteroid class that you will inherit into the other one. So the big asteroid, the little asteroid, blah blah blah. Yeah. And we will discuss this on the next stream, because me coding the asteroid now will just be too long-winded and boring, because I got to work out the vertices. Yeah. And I didn't really want to do a stream all the way because I want to play Halo Wars. Mrs. OSK's beating me on Halo Wars, and I can't have that. I can't have Mrs. OSK beating me on Halo Wars. Can't have that. Can't have that. I was gonna stream it, but I haven't figured out how to get it across. I think I can stream onto here and then stream out. I think. But that's the homework. So if you want to try, we're going to try, like I say, we're going to try and create the asteroid game in using C++ in SDL. Yeah. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.